Okay, so I hope that makes sense for the first two parts of that problem. And I want to sketch the last part of this, sort of give you an idea how the third idea might work. But I mean, this is actually maybe not the third, it's just the third idea I had. Okay, so first of all, you decide which box to put the 2's in. When you put 2, you have to put 4, 6, and so on, all the way up to all the even numbers up to 100. Okay, and then you pick which box. Well, you don't have a choice where to put the 3, because if you put it in the other way, the 6 would have a common factor with a 3. So then you're forced to put all the multiples of 3 here as well. Okay? And if you think about it, you have to put all the multiples of 5 because of 10. Okay? And actually, all the numbers less than 50 you have to put in here. Okay? Because doubling any number less than 50 will still be less than 100. And so it will have a common factor with its double over here if you put it over there. So all the numbers from 1, okay, obviously except 1, because 1 still only has a common factor of 1 with itself, with doubling itself. So basically all the numbers from 1 to 50 except for 1, and then all the even numbers onwards. Okay. So actually, if a number is not prime, if a number is not prime, then the numbers are less than 100. So if the number is not prime, then one of its factors is less than 10. So that'll be in here. So then basically the only numbers that could go in here would be prime numbers bigger than 50. Okay. So, the kind of numbers that could go in there would be, so 51 is not prime, 53. Well, actually, I'm not saying these are prime, but these are the ones that are not yet, obviously not prime. So 55 is not prime, 57 is not prime, 59 not sure about. So these are maybe the numbers you would check. Yeah, 63 is not prime, 55, 67, 69 is not prime, 71, 73, maybe that's not prime either. So 77, 79, 81 is not prime, 83, 87, 89, 91 doesn't sound prime, but it could, we should check. 93, 97. Yep. And so to sort of finish off this idea, we determine which of these numbers is prime. And we see that these are the only numbers, the prime ones are the only ones that can actually go into the other box, along with 1. Okay, and then it's just a matter of figuring out what are the possible ways of putting various balls here into that box. And one way you can distinguish them, for example, is if you had 2 numbers here, it'd be different than if you had 3 numbers. Okay, so that's one way to really get a systematic way to count the number of ways of splitting these up like that. Okay, so you can see one thing is just a matter of calculation, is checking which of these is prime, and then sort of count the number of ways you can pick none of them, which is just 1, I guess, 1 of them, which is however many there are, 2 of them, 3 of them, all of them, yep. And that would be the number of ways you can split the balls up.